Dear students, today we are going to talk about chemical hazards, one of the main health risk sources in the working environment. We are surrounded by the chemicals everywhere. The moment we wake up in the morning, we start to use chemicals, and the moment we fall asleep, we are still surrounded by chemicals. Toxic substances can be everywhere. First, of course, the industrial chemicals, but also natural toxins, such as many plants and animals produce toxic substances, or environmental pollutants, food additives, drugs, and so on. The science which studies the chemicals and their effects on living organisms is called toxicology, and its founder is a Swiss philosopher called Paracelsus. The idea behind it is that chemical has its toxicity, and once you are exposed to a chemical, you may develop a toxic effect. If the chemical is away from you, for instance closed in a cabinet, in a closed package, then it doesn't pose any risk to you because you are not exposed to it. But once you start to expose to it, you may develop a toxic effect. Paracelsus said an important sentence. It says that all substances are poisons. There is none that is not a poison. The right dose differentiates a poison from a remedy. This means that the longer you are exposed to a chemical and the stronger the dose, the more dangerous the chemical is for the person. So even water can be toxic for us if we drink it too much and the body cannot deal with it anymore. After Paracelsus, there have been several studies about chemicals and their hazardous properties, starting with an Italian doctor called Ramazzini, who wrote a book about workers' diseases. And it was a book about those diseases which harm the workers' lungs, such as asthma and other problems with breathing. Ramazzini also said that in order to stay the workers healthy, we need to protect them from the dangerous chemicals. And there is no use for the worker to send to the hospital and treat him if he is sent back to the same working environment. He starts to breathe in the same chemicals and will be sick again. But it took several years or even centuries before chemical legislation and safety measures started to develop. A lot of other studies were needed before that. Many of those studies concerned carcinogen chemicals, the ones which cause cancer. There were studies in England, in Germany, and in 1940 a massive and important study was conducted which connected asbestos with cancer. Asbestos causes lung cancer due to its very specific fiber which sticks to the lungs very easily. You cannot breathe it out and eventually causes cancer. So nowadays asbestos is prohibited from the products, but you can still find it in the working environment, for instance in construction site, in demolishing buildings. So there very strict safety measures apply. So in order to protect workers, we need to know what is behind the toxic chemicals. So we take this liquid, which is in a glass. It's a transparent liquid, and usually we think of this liquid as water. If it has no label, we suppose we can drink it. But actually it can be anything else. It can be ethanol, it can be methanol, or even something more dangerous. Of course, then, we would expect it to be labeled, like this windshield washer liquid, which consists of methanol and has adequate safety pictograms on the label so that we know how dangerous it is. So label is our first source of information about the product and what we can find inside it. In European Union, we protect workers from chemicals through several different directives. The main directive comes from the year 1998, which says that the employer shall ensure the workers with adequate information on the hazardous chemical agents occurring in the workplace, its hazardous properties, for instance, whether it is carcinogenic, whether it can impair your lungs or your liver or your fertility system, but also the actual level, type and duration of exposure, any occupational exposure limit values or biological limit values established, and the effect of preventive measures taken or to be taken. The employer shall also ensure appropriate training and information about the appropriate precautions and access to any safety data sheet provided by manufacturer or supplier. The legislation also defines what is a chemical agent. In short words, it is a compound which is a pure substance or is mixed. And activities involving chemical agents can be anything, any use of chemicals such as production, handling, storage, transport or disposal and treatment. So chemical agents are pure substances or mixtures, and we use them in different steps in our working environment. Here is an example about a product which consists several toxic substances such as zinc oxide, Pronopol and other chemicals. So the mixture is especially difficult to assess because each of these chemicals have its original toxicity, which can be dangerous to the health, but we often don't know how they are acting together. They can be synergistic or antagonistic, which means that sometimes two chemicals can have even more serious effect, but sometimes the toxicity can be less. In European Union, you can market chemicals only then when you have determined the dangerous properties of this chemical, have also assessed the risk for health, environment and property, and have classified, identified, packed and marked this product. So all chemicals, both substances and preparations, should have a clear marking. And we have chemicals such as water, but we also have those chemicals which we classify as hazardous. The hazardous classification can be because of the toxicological properties of the chemical agent, like the chemical can be corrosive to skin or irritant to our eyes, or carcinogenic, or can impair our liver, but also because of physicochemical properties such as flammability or ability to explode, and temperature and pressure of the agent, and physical manner in which it is used or handled. We need to keep in mind that besides the packages which should be labeled, we also need a longer information about chemicals toxicity, which is presented in safety data sheets. So, the chemicals which are in European Union market should be labeled and should have a safety data sheet. And list of dangerous chemicals you can find in European Chemicals Agency's webpage. So what does the label need to have? The correct label has the chemical's identification, the manufacturer's identification, and also the intrinsic hazards and The pictograms, the signal words, danger or warning, hazard statements, precautionary statements, and the quantity of the content of the package or container. The hazard pictograms come from the CLP-GHS hazard categories. You can find more information about it in a separate video which I have given you a link. But the chemicals are classified through physical hazards, through health hazards, and through environmental hazards. They can be explosive, they can be flammable, they can be oxidizing gases, solids or liquids, they can be compressed or liquid gases, and corrosive materials, both to skin as well as to eyes. They can be acutely toxic, oral, thermal, or inhalative. They can be eye irritants, skin sensitizers, but also toxic for specific target organs. They can be carcinogens, mutagens, or reproductive toxicants, and they can be harmful to the environment. So each of the toxic chemicals should have an adequate information through hazard pictograms, but also the label should consist the hazard statements, which are the expressions which show the nature of special risks attributed to dangerous substances and preparations, such as an extremely flammable gas, fatal if swallowed, may cause cancer, and so on, and precautionary statements such as keep out of the children, protect from moisture, protect from sunlight. These are statements which are expressions where the safety advice concerning dangerous substances and preparations is presented. So there is an example of a label. The name of the chemical, the hazard word, the hazard statements, the precautionary statements, and also the identification of the supplier or the manufacturer. And of course, hazard pictograms. Besides the label, we need safety data sheet, which is a longer information. It provides professional users the information about the hazards posed by the product. And it is written in the language of the country to which the supply is made, and it must be also dated. The safety data sheet has 16 different parts, and you can hear more about safety data sheets through a separate link to a video which I have given to you separately. Of course, also we need to measure the chemicals in our work environment here. And we have occupational exposure limits, which every country has set, and also some of the limits are used by all European Union. So an occupational exposure limit is an upper limit on the acceptable concentration of a hazardous substance in the workplace air for a particular material or class of materials, which still doesn't consist any severe health problem. We can measure chemicals in the working environment within different methods. Here you can see a method which measures through interspec and through spectrums. So we measure the chemical spectrums and determine them in the workplace air. It is very important also to know how to control chemical hazards. You can control them at the source through elimination, reduction, and substitution, which is considered the most effective, but the most widely used is of course control along the path, especially local exhaust ventilation. But it's important to control also the chemicals at the worker, like personal protective equipment, and have adequate work practices such as safe practices and also equipment maintenance. This was a short lecture about chemical hazards. Thank you for listening.